of those who might
This
want to
meeting
join.
is being recorded.
Yeah. So, by the way, can you see my screen yet?
Yes, I can see.
Okay. So last week, yeah, I think people are joining now. So last week we covered some part of tutorial 2. So then, yeah, please, and this one, could you just, admit all of them for me? I've made you a co-host.
Okay.
Okay, so. Thank you. So last week, I discussed some part of tutorial 2 for you in particular functions. So we did the same thing as mapping. Then I related it to Cartesian product and relations. I said Cartesian products, it's the ordered pairs of elements A and B. You understand now? So, and a Cartesian product with a kind of what do we call it? Maybe a kind of relationship. So then we call it a relation. I hope you understand now. Then I said a relation can be a function when, if all the elements in the codomain, are filled up. I hope you understand now. And maps to a unique element in what? So in the codomain. Also, I explained the meaning of codomain, domain, range, pre-image, and how you can find them. So yeah, and we discussed about the usual logarithm also. So, but today I'm going to start with system of equation. So in particular, matrices. I learned some of you are finding matrices difficult. So, but what I'm going to do is that immediately we cover matrices. So addition, subtraction, and multiplication. So what I'm going to do after that is to tell you,
go to the Outlook.
You said? Hello, can you hear me, please? Hello? Are you talking to me?
Someone was asking where they could find the link, but I've copied the link onto the group chat on WhatsApp.
Okay. Yeah, okay. Thank you so much. And this one. So then immediately we're done with matrices. Did you find it? Say it again. Ruzani, what's your question?
Yo, sorry, sir. I thought I muted myself. I'm so sorry.
Oh, no problem. It is fine. Yeah, it is fine. So, yeah. So, yeah, before we continue, so what I'm going to do after this is, after explaining the matrices, then I'm going to tell you the nature of equation. We have, a unique solution. An equation can give you, a system of equation can give you a unique solution. So you can have, no solution, and you can have infinitely many solutions. So I'm going to discuss every other thing. Then I'm going to discuss Gauss Jordan equation as well. So what we call augmented matrices, and how you can use this idea to solve system of linear equation. Hope you understand. And like I've used to say, at any point in time, if you have questions on what is not clear to you, please feel free to ask, and I'm going to reply you. Okay, now to start with, when we say matrices, matrices is the plural form of matrix. So matrices is the plural form of matrix, and it is nothing but the rectangular arrays of numbers enclosed within brackets. I hope you understand now. That is when you say something, it's an arrays of number. So that is when you arrange a number in terms of what? In the form of rectangle, you have the matrices. Let's say, for example, if I have this sum, there's something of this nature: 1, 2, 3, 4, 5, 6, 7, 8, 9. You understand now? So you will see this is an array of numbers. Indeed, this array of numbers is in what? Is in form of what? So it is in the form of rectangle. I hope you understand now. So such array is called matrices. You understand now? And you know, if I put a dot here, 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 and here, you will see it forms a rectangle. I hope you understand now. So if that is clear, we denote a matrices by an uppercase letter. I hope you understand now. So matrix is denoted by an uppercase letter. And all members of a matrix, for example, 1, 2, 3, 4, you understand that. All those numbers like that. So they are the elements of matrix A. I hope you understand that. So in essence, 1 here, 2, 3, all the numbers inside this are called element of matrix A. Yeah, I can go over the solution, but as far as I know, many of your colleagues, they don't have some of the idea. What I want to do is to quickly give you, a short form of it. Then after that, we can go through the solution. You understand? Although I'm going to go through the solution as well. You know, for example, now, if I just go through the solution, why some of you are still not getting the concept, you know, that might be a problem. You understand? So yeah, don't worry, we are going to go through the solution. We are going to go through them. So yeah, that is that. So if that is cleared, I said the element that runs from your left to the right now, they are called the what? So they are called rows of a matrix. So an element that runs from top to bottom, this guy, they are known as what? They are known as the columns. I hope you understand now. So, and you can have different types of matrix. So we have number one, we call something row matrix. When we say row matrices, so it's a matrix with what? Just a single row of elements. I hope you understand now. So for example, if I have something of this nature, 1, 2, 3, so you can see that I'm having how many rows here? So I'm having just a single row. Don't forget I said the row is what? Element that runs from your left to the right. I hope you understand now. So this is row. So please mute yourself, guys. So if your matrix, has just a single row, that is a matrix of 1 by n matrix. 1 by n matrix is called a row matrix. So this 1 by m is called what? The order of this matrix. You want to know order of a matrix? Just count the number of rows as well as the number of columns. So that will give you what? The order of the matrix. For example, now you will see that this matrix has 3 rows. So, and 3 columns. Can you see? 1, 2, 3. So 3 rows and 3 columns. Then this matrix is said to be what? A matrix of 3 by 3, or that 3 by 3. Likewise, for column matrix, let me be fast so that we quickly go to the question. So for column matrix, we have what? So we have, we said a matrix of n by 1 matrix. That is a matrix with just a single number of column. A single column. So for example, when you have 1, 2, 3, you can see that we only have a column here. Don't forget I said a column is an element that runs from what? From left to the right. From top to the bottom. You see, we only have just 1 column. So, but I have just 3 columns. In essence, when you have 1 column, and you say that column is what? That matrix is known as a column matrix. Likewise, we have a square matrix. When you say square matrix is a matrix whereby the number of rows is the same thing as the number of columns. So where the number of rows is also equal to the number of columns. So it's equal to the number of columns. So we call it an n by m matrix. So it is called an n by m matrix. Please, guys, help me, assist me to admit your colleagues that are just joining so that they don't confuse me. I've made some of you, co-host. So Simfui, perhaps maybe I should also make you co-host. So, and if anybody joins, just take them inside. Yeah, thank you so much, guys. So, if that is clear, we know what square matrix means. Likewise, we also have an identity matrix. Don't forget, I said square matrix is a matrix with, an n by n matrix. That is when you have the number of rows equal to the what? Equal to the numbers of column. So that is a square matrix. So, but for identity matrix, or before I continue, we call something a diagonal matrix. So, well, let me just describe it this way. When we say identity matrix is a square matrix. So where all the elements are 0 except those along the leading diagonal. I hope you understand now, except those along the leading diagonal. For example, when I have 1, 0, 0, 1, you will see that all these matrices are 0 except this one, which is what? Which is 1, 1. So they are 0 except those along the leading diagonal here. So likewise, when I have 3 by 3 identity matrix, that's 1, 0, 0, 0, 1, 0, 0, 0, 1. I hope you understand now. So then you will see that all the elements here are also 0, except those along the leading diagonal like this. I hope you understand now. So that is that. So, and if that is cleared, we know identity matrix. So we know what square matrix means. Let me quickly rush to the operation of matrices so that before we start, you understand what it means. So for the operation of matrix, we have what? Addition. To add and subtract two matrices together is not difficult. So what you have to do before you can add or subtract two matrices together is that they must be of the same order. I hope you understand now. Let's say, for example, if my matrix A is equal to 1, 2, 3, 4, and my matrix B is equal to 4, 5, 6, 7. So we can add A and B together because A and B are having the same dimension. Indeed, who can tell me the order of A? What is the order of A? Anybody? So, you know, the order of... Hello, guys, please, can you mute yourself? Please, guys, mute yourself so that you don't destroy the session. So, if I now have A plus B now, like I've asked, the order of this matrix A is what? 2 by 2. The order of this matrix is also what? 2 by 2. So since there, don't forget, how do you know the order? Just count the number of rows, 1, 2. You understand now? Likewise, the number of column, 1, 2. So, I mean, the number of column by the number of rows by the number of columns is what will give you the order of that matrix. So if you now want to add this matrix together, then you now add row 1, column 1 of this first matrix with row 1, column 1 of the second matrix. Then row 1, column 2 of the first matrix with row 1, column 2 of the second matrix. So in essence, so if I want to add A and B together now, you don't need to stress yourself. This is going to be 1 plus 4, 2 plus 5, 3 plus 6, and then 4 plus 7. I hope you understand now. So, and if you now check it together, it's gonna give you 5, 7, 9, 11. I hope you understand now. So that is addition. So likewise for subtraction, it follows the same approach. What you have to do differently is that instead of you adding, you just subtract. So it means my A minus B, before you can subtract two matrices together, don't forget, you must have the same order. And God so good, A and B are having the same order 2. Then if you subtract them together, then I'm going to have 1 minus 4. That is row 1, column 1 of this first matrix minus row 1, column 1 of the second matrix. This is going to give me 1 minus 4, 2 minus 5, 3 minus 6, 4 minus 7. And if you check it very well, then I'm going to have what? Minus 3, minus 3, minus 3, minus 3. I hope that helps. So if that is cleared, so you know how to add and subtract matrices together. So what of multiplication? Matrix multiplication. You can do two things in multiplication. You understand that we have two types of multiplication in matrices. The first one is scalar multiplication, whereby you multiply a scalar by a matrix. Sorry guys, before I continue, let me just send you the attendance so that you can fill it. So just a minute. Just a minute, guys. Okay. Yeah, I just sent you the attendance on the group. Please refer to it and fill it. So we have two types of multiplication. The first one, we have scalar multiplication. Scalar multiplication. Then the second one, we have what? Matrix multiplication. You understand now? So matrix multiplication. By scalar multiplication, I mean when you are multiplying a scalar by a matrix. For example, again, if my matrix A is 1, 2, 3, 4, I hope you understand now. And I now ask you to find 5A. This 5 is a constant. We call it a scalar. So you understand now. So you can multiply a scalar by a matrix. Then I'm going to have 5 multiplied by 1, 2, 3, 4. And that's going to give me what? 5 times 1, that is 5. 5 times 2 is 10. 5 times 3, 15. 5 times 4, that will give you 20. I hope you understand now. So that will give you 20. So that is for matrix multiplication. But when you want to multiply two matrices together, before you can multiply two matrices together, they must be conformable. I hope you understand now. Again, so before you can multiply two matrices together, two matrices, before they can be multiplied together, so they must be conformable. So they must be conformable. So they must be conformable or defined. When we say two matrices is conformable or defined, that is when the row of the first one is same thing as the column of the second one. I hope you understand now. So just take for example again, if I have my matrix A to be 1, 2, 1, 1, and my matrix B is 1, 1, 2, 2. So if you now want to find A multiplied by B, it is not difficult. So A multiplied by B, before you can multiply them together, you have to see that they are what? They are conformable. I hope you understand now. How do you know they are conformable? What is the order of A? What is the order of A, guys? The order of A is 2 by 2. And the order of B is also what? 2 by 2. If you can check and see that the column of the first matrix is the same as the row of the second matrix, then you can conclude adequately that the two matrices are conformable. In essence, they are defined. That is, you can multiply them together. So, and when you multiply them together, you are going to get what? Matrix 2 by 2. You understand now? And how do you now multiply them together? Wait, guys, you have 1, 2, 1, 1. So multiply by 1, 1, 2, 2. I hope you understand now. So if you now want to do that now, just check this one now. You know, this is rows. We have two rows here. This is the first row. This is the second row. Then this is first column here and the second column here. So if you want to multiply two matrices together, you have to multiply row by row with columns. So this row, so this rows here, you multiply it with both columns here. I hope you understand now. These rows, you multiply with, you multiply by these two columns here. And how do you multiply? So if you want to multiply, let's say if I'm multiplying this row by these columns, it means you are going to say the first element here multiplied by the first element here plus the second element multiplied by the second element. I hope you understand now. So in essence, so this is going to give me what? 1 times 1, then plus 2 times 2. You can see now, we are multiplying row by columns. And we have what? We have 1 row here and 2 columns here. It means you are going to use this same row to multiply 2 columns of the second matrix. So then immediately you are done with that, you still take the same row here by this column. I hope you understand now. And that will give you 1 times 1, 1, then plus 2 times 2, that will give you 2. I hope you understand now. So yeah, that is fine. Then you still take the same row here, you multiply it by this column. So that will be what? 1 times 1, 1, then plus 1 times 2. That is 2. You understand now? Then don't forget, I said you multiply row by columns. Then the same row here, you multiply it by this same column. I hope you understand. So that's going to give you 1 times 1, 1. Then plus what? 1 times what? 1 times 2, that is 2. Then you can now add them together. So this will now give you 1 times 1, 1 plus 4, 1 plus 4, 1 plus 2, 1 plus 2. So then what do you have later? That is 5, 5, 3, 3. So 5, 5, 3, 3. So that's how you are going to multiply it. Okay, now, what if you have 3 by 3 matrices before we move to, Gauss Jordan elimination method? What if you have 3 by 3 matrix? Or let me say I have this type of matrix. If my A is equal to 1, 0, 1, 1, 2, 0, 1, 1, 1, that is A. This is a 3 by 3 matrix. You understand now? And maybe my B is what? 3, 1, 1, 1, 1, 1. So, okay, let me rewrite it. I want to ensure that they are conformable 3, 1, 1, 0. Okay, now, so we have matrix A. If you check the order of this first matrix, you know it is 3 by 3 matrix. And the order of the second matrix is what? How many rows do we have here? If you count the number of rows, we have 1, 2, 3. So we have 3 by 2 because our column is what? Our column is 2. And I said for your AB now, you have to check that they are what? They are conformable. How do you know they are conformable? That is, if the column of the first matrix is equal to the row of the second matrix. Indeed, the order of A is what? 3 by 3. And the order of B is also what? 3 by 2. You see that the column of the first matrix is equal to the row of the second matrix. Then you can conclude adequately that they are conformable. That is, you can multiply 2 of them together. I hope that is clear. Guys, I hope you are following me. So yeah, then after you've done that and you've established they are conformable, so then you can now multiply them together. 1, 0, 1, 1, 2, 0. So 1, 1, 1, because I want to finish everything so that we use the remaining hour for question and answer on what is not clear to you. So 3, 1, 2, 1, 1, 0. I hope you understand now. Okay, now again, don't forget I said you multiply rows by columns. You multiply rows by column. So the same row here, you multiply it by these 2 columns. And don't forget, if you are multiplying row by columns, so then this is going to be what? First element here multiplied by the second, first element here, that is 1 times 3. That will give you 3. You understand now? Then you have 3 plus 0 times 2, 0 plus 1 times 1, 1. So then you take the same row and multiply it by this second column. That is 1 times 1, 1 plus 0 plus 0. Then 1 times 3, 3 plus 4 plus 0. Then lastly, 1 times 2 plus 0. Then the same row with columns, that is the third row with the 2 columns. That is 1 times 3, 3 plus 1 times 2, 2 plus 1 times 1, 1. I hope you understand that. Then the same row here with this column, that's going to give me 1 plus 1 plus 0. So then I'm going to have 4, 1, 7, 3. So then this will give you 3 plus 2 plus 1. That will give you 6. I hope you understand now. So, and this is 2. I hope that helps. Okay, now let's say the question, because you might have this, you know, A and B is defined. Can you tell me, is B and A defined? In essence, can you multiply B and A together? I mean, like in general, is multiplication of matrix commutative? Is it commutative, guys? Anybody, please, let us be fast. Anybody? Is it commutative? No, thank you, Ahona. So it is not commutative. It is not commutative. Yeah, so because, you know, our A, B here, this is my A. Our A is what? 1, 2. You know, if you rewrite it, remember, I said before you can say something is defined or before you can multiply them together. So the row of the first matrix must be equal to what? So the column of the first matrix must be equal to the row of the second matrix. It means you cannot multiply them together. So if that is clear, any questions so far before I move to Gauss Jordan elimination method? Any question? Hello guys, any question? Okay, in the absence of no question, let us talk about system of linear equation. System of linear equation. In my first, class, I made mention of linear equation. What is a linear equation? That is an equation with what? So equation whose highest degree is what? The highest degree is 1. You understand now? So, and an example of that is when you have something of this nature, x plus 3 is equal to 5. You know this is what? Is a linear equation. But this linear equation can now become system of linear equation when you now have 2 unknowns. For example, now if I have 2 unknowns now, so I'm interested in finding the values of the 2 variables simultaneously. For example, if I have s plus y is equal to 3, and maybe 2s plus y is equal to 5. You can see both of them are what? Are 2 linear equations. Are 2 equations, 2 linear equations in 2 variables. So it is linear equation in 2 variables, and our variables here is what? Sy, xy. I hope you understand now. So indeed, you can make sense of this. Or you can rewrite this in the sense of matrix. This is going to give me, just write the coefficient of each of the variable. This is going to give me 1, 1, 2, 1. You understand now? 3, 5. So what you've done here is known as augmented matrix. So it's known as augmented matrix. That is when you can write your system of linear equation in the form of A is equal to B. You understand now? So where your A represent the what? Where your A represent the coefficients of the unknowns. I hope you understand now. So then your S is the what? Is the variables, maybe the S or Y you want to find. And your B is what? So your B is the constant. So it represents the constant. So if that is clear, we have 3 types of solution. Let me quickly rush that as well before I move to Gauss Jordan. Then after that, you can ask questions on what is not clear to you on what we've covered so far. So when we say system of linear equation, the first one we have, a system of linear equation can give 3 different types of solution. Number 1, you can have a unique solution. I hope you understand now. So you can have a unique solution. So when we say unique solution is maybe when you find the value of this variable. So for example, at the end of the day, if we solve this simultaneous linear equation, then I have that my x is equal to 3 and my y is equal to 2. You understand now? Then we have unique solution. In essence, when you represent this in graph, I know you understand how you can represent something in graph. So you are going to notice that your two graph is going to intersect. In essence, the point of the intersection is the solution of that two equations. This is what I'm trying to say. When I have s plus y is equal to 5 and s minus y is equal to 3. I hope you understand. Now, if s plus y is equal to 5 and s minus y is equal to 3. So, you know, if you want to solve this simultaneously, maybe you want to use any of your method, maybe elimination method or substitution method. Maybe I just add the two equations together. This is going to give me 2s equal to 6. So which implies that my s is equal to what? 3. I hope you understand now. So from here, since I know that my s is equal to 3, if I substitute s to be 3 here, then I'm going to have, or maybe I call this equation 1, equation 2. I just say put s equal to 3 in 2. So then you are going to have s minus y is equal to 3. Then I'm going to have 3 minus y. Oh, sorry, I want to put 1 here. Let's say this is y. So 3 minus y is equal to y. It means my y is equal to 2. So you can see that my s is equal to what? 3, 2. That is, y is equal to 3 and y is equal to 2. When you simplify it and you have this kind of solution, we call it a unique solution. And when you now represent a unique solution, so you are going to notice that the point is going to intersect. So for example, if you want to locate this in the graph, let's say I have s plus y is equal to 5. So, you know, s plus y is equal to 5, and you have s minus y is equal to 1. Let's say I want to grab this function. If I want to grab this function, you understand now? You know, this is the same thing as if you rewrite y, that's y is the same thing as 5 minus x. You understand now? So, and y for the second equation, it's the same thing as what? S minus 1. So this is 5 minus s, and this s minus 1. Okay, let me just take some points of y. So let's say if my s is equal to 0, maybe I have 5 here. So I have 5 here, and I have 10 here. I have minus 5 here, and I have minus 10 here. So I have minus 5 here, I have minus 10 here, I have 5 here, and I have 10 here. That is my s axis. So, you know, if my y, I mean, if my s is equal to 0, that is at the point of origin, if my s is equal to 0 here, then I'm going to see that my y is going to be 0. My y is going to be 5. So if my s is equal to 1, you know, it's going to be somewhere around there. Then I'm going to see that, you know, we substitute the value of 1 here. So then you are going to have that your y is equal to 5 minus 1, which is going to give you 4. Then you have something of this nature. Okay, let's say your y is equal to 5, then this is going to be 0. If I don't want to waste my time, then I'm going to have a straight line graph, something of this nature that will cross across it. You understand now? Likewise, if you do it for the second one too, let's say your s is equal to 0. If your s is equal to 0, your y is going to be minus 1, which is something of this nature. You understand now? So if s is equal to 5, then you are going to have, I mean, if your s is equal to 5, you know 5 is here, you are going to have y to be 4. I hope you understand now. Then if y is equal to 10, for example, then I'm going to have y to be 9, which is something around here. If you join the line together as well, you understand? So what I'm trying to say now is that this point of intersection, so if you trace it to y-axis, which is here, and you trace it to s-axis, it will be your solution. And if you take it very well, you can see it looks like what we had here. So in essence, when you say something is a unique solution, so then the points, when you plot the two, the two equations on the graph, then you are going to see that they are going to intersect. They are going to intersect. Okay, now, when we have no solution, we can have no solution. Don't forget I said we can have unique solution. So just a minute, we can have a unique solution, which I've demonstrated above. We can have no solution. We can have no solution. Then we can have infinitely many solutions. You understand now? So then for unique solution, I derive that is you have just unique value of x and y. But for no solution, they are parallel. So, but they have different what? They have different, they have different intercepts. Indeed, we have the same shape. You understand now? You know they are parallel. Excuse me. So they will be parallel. Maybe, for example, if my y, or maybe I have x plus y is equal to 5. So then I have 2x plus 2y is equal to 10. You understand? Okay, I'm not referring to this type of solution. Look at this. If I have s plus 2y is equal to 6, s plus 2y is equal to 2. You understand? So if you look at this very well, you will see that they're having the same slope. How do you know slope? You know the general formula for a linear graph is y is equal to what? ms plus c. So where your m is the slope. You know, if you rewrite this as the form of y is equal to ms plus c, it's going to give me 2y is equal to 6 minus x. That will give me what? Y equals what? 3 minus x. And this implies what? Y equals 2y is equal to 2 minus x, which implies y is equal to 1 minus what? So 1 minus x over 2. I think this is also x over 2. This is also x over 2. So if you check them very well, you will see that we have the same slope. You know, I said slope is just the what? It's just the coefficient of x. Hello, please, you are distracting us with what you are doing. So you will see that they have the same slope but different intercepts. So when you have this type of equation, in essence, if you graph them and you have something of this nature, you understand now, you can see that we have the same slope but different intercepts. They didn't start the same place. Then we say such equation or such system has no solution. I hope you understand now. So we have no solution. But for the next one is infinitely many solutions. Don't worry, I will give you an example. Infinitely many solutions. For infinitely many solutions, they are of the same words. So when solutions are exactly the same, or let me say when the system are exactly the same. You understand now? And if you plot that inside your graph, so something of this nature, so then you are going to see that the graph of the first one will also be along this second one. So they would lie on the same point. So they will lie on the same point. I hope you understand now. So that's that. If you now understand that geometrically, let me give you one hint. I used to do that. So when you are solving your system of equation and you now find unique value for x and unique value for y, you don't need to stress yourself. It is a unique solution. I hope you understand now. And maybe when you are doing it, at the end of the day, you now have, you know, for something to be an equation, you must have the left-hand side equal to the right-hand side. Maybe at the end of the day, you now have 0 equals 5. I hope you understand now. So maybe you have 0 equals 5, for example. You know 0 cannot be equals 5. So then when you have something of this nature, maybe when the left-hand side is not equal to the right-hand side, then what you have is known as what? So we have a unique, no solution. So no solution. But for infinitely many solution is when you have something like this. Maybe you have 5 is equal to 5, or the same number, or you have 0 equals to 0, or something of that nature. So you have infinitely many solution. You have infinitely many solution. So let me give you an example to back it up. Before we continue, do you have any question? Any questions so far, guys, please? Let us talk. Or do you understand what I'm trying to explain so far? So you have your time to answer the question now. Or maybe should I quickly explain Gauss Jordan solution, then from there we can take the question together.
Yes, please.
Okay, let me explain Gauss Jordan equation so that we can take the question together. Excuse me, guys. So if you are just joining us, so I've just sent the attendance on the group again. So please fill it. Okay, let us quickly take Gauss Jordan equation. Gauss Jordan elimination method. Gauss Jordan elimination method. So one of the application of matrices is you can use it to solve system of linear equation. And there are many ways you can use to solve system of linear equation. One of them is to have a row reduced echelon, or to reduce your system to what? To a row reduced echelon form. When we say a row reduced echelon form is maybe I have something of this nature, maybe 1, 2, 3, for example. Then you have 0, 1, 2, 0, 0, 1. You understand now? So when the first element here, the first element of the second row is 0, and the first two elements, in the third column is 0. Even if you have 4 of them, maybe I add another element to this, you can have the first row something of this nature. You understand now? So then we call this an echelon form. We call it an echelon form. And you know the advantages of this is that maybe I want to solve an equation, so involving 4 variables. You know, when you have 4 variables like x, y, z, w, then you don't need to stress yourself. You can just simplify it backwardly. I hope you understand now. So, and this will now be what? 4. You know, this will be 4 set now. For example, maybe I have x, y, z, w. And you know, if you multiply this, don't forget the matrix multiplication I taught you, you multiply row by columns, then this will be what? X plus 2y plus 3z plus 3w. You understand now? And so on and so forth. So, you know, if you move to the third, to the last line is going to be 4w. From there, you can know the value of w. Once you know the value of w, you substitute there to find the value of z. Once you know the value of w and z, you substitute there to know the value of y. Then once you know that, you substitute that to know the value of x. Someone is posting on the chalkboard. So the class will end at 6 o'clock. But if you have a question now, maybe we should give you a priority. What's your question? What is it about? So before I continue with what I'm explaining, so that you can go for your test. Can you mute yourself, unmute yourself and tell us your question? Afilele, are you there? Can you ask your question now? Okay, I think it's not with us. Okay, yeah, let's continue. You will see the beauty of what I'm saying now. Okay, let me use that to, maybe you have s plus y is equal to 5, like we done the other time. S minus y is equal to 3. So, you know, you compute this. If you want to put this in an augmented form, what do I call augmented form? That is, you have it in the form of ax is equal to b. You understand now? So you have it in the form of ax equals to b. And don't forget, I said your a is what? The coefficient of the unknowns. What's the coefficient of s here? That is 1, 1. You understand now? So then it's going to give me what? 1 minus 1. I hope you understand now. And then you can write this value here. That's when you want to use row reduced echelon form. At times, you can, maybe the question may ask you to find A directly. Maybe what will be the augmented value of A? This will just be your A. You understand now? So this is your A. So then your B are just the constant. You will understand what I'm trying to say now. Let's say we want to solve this. I want to use row-reduced echelon form. So before, I think you should understand what row-reduced means before we move to Gauss Jordan elimination method. So what we are interested here is that this guy, the first element here, the first element along the leading diagonal here must be 1. You understand now? So if it is 1, then the next element here, we are interested in making it to be 0. You understand now? So, and you are going to do a kind of manipulation to ensure it is 0. So that when it is now 0, then that will enable us to find the value of our S now, since we know that this is just S, this is Y. I hope you understand that. Then how do we do that? First of all, make this one to be 1. Then after that, you just write this 1, 1. You understand now? Then you put 5 here. Then how do we make this to be 0? Then you now use the relationship. Yeah, can you hear me now? Sorry, I got lost before. I think that was my connection. So we are interested in making this 0. So what you can do to make this to be 0 is to what? You can just subtract row 1 from row 2. You understand now? Just subtract row 1 from row 2. Then this is going to give me 1 minus 1. That is 0. And what you do for this guy, you must as well will also be what? 1 minus minus 1. You know, 1 minus minus 1 will give me what? Hello? So 1 minus minus 1, so that will give me 2. So that will give me 2. I hope you understand now. That will give me 2. Then this one, 5 minus 3, that will also give me 2. So the advantage of this is now that now I've made this to be 0. If I rewrite it back, I mean, in the system of equation form, then this one will give me what? You know, it's going to give me S plus Y is equal to 5 again. You know, S now is 0. Then it means it's going to give me 2Y is equal to 2. And from here, I can say my Y is equal to 2 divided by 2, which is 1. Since no, your Y is equal to 1, you can just put it here. So then your Y will now give me what? No, sorry. I think, yeah, am I talking sense? Okay, yeah, I'm correct. We wrote 3. So then Y will now be what? If Y is equal to 1, then you put it into this first equation, then you have S plus Y is equal to 5. Then S plus 1 is equal to 5, which implies S is equal to 5 minus 1. That is good. Okay, but what if you have 4 equations? Let's say I have S plus O. Let me use one of your tutorial question. Yeah, let me use one of your tutorial question. Just a minute. Let me just copy it from here. Hello, guys, are you still with me? Hello?
Yes.
Yeah, thank you. Okay, look at this question. So I think you can, yeah, let us quickly solve this. You can do it before we solve it. Snipe. It's one of your tutorial question. Sorry, I'm trying to copy it there. Here you go. Okay, look at this. The question says, write the augmented matrix corresponding to the system of equation. That is not difficult. How will you do that? Number one, you know we have 3x. Look up, we have 3x minus z is equal to y. Y minus z is equal to 3. S plus y is equal to minus 1. I think they choose this question from former MCQ question, so it might likely, you might likely find, I mean, a related question in your exam, I mean, your assessment. I don't say this is coming, but you can find this question. So before you can do that, then you have to arrange it first, you know, in the form of x, y, z. You know, this one is going to give me what? 3x minus y minus z is equal to 0. You have to arrange it first so that you don't make mistake. Likewise, we don't have x here. Then you can start from y directly. Y minus z is equal to 3. And this one will give me what? S plus y is equal to what? Minus 1. You understand now? So it means if you now want to, I mean, if you want to convert this, guys, please, can you see my screen?
Yes, we can see it.
Yeah, thank you. So to write this in augmented matrix, don't forget, you write the coefficient of each of the variable. So, and this is going to be 3. This will be minus 1. This will be minus 1. Then you write it here, this will be 0. I hope you understand that this is what you have on the other. That's why I advise that you rearrange it first. Okay, for x, what are you going to have? You know, we don't have the coefficient of x here. It implies x is equal to 0. This is going to be 0. This is 1. This is minus 1. And this is 3. I hope you understand now. Likewise, this is going to be what? 1. 1. You know, we don't have for z. Then this is going to be what? 0. And this is going to be minus 1. That's how you are going to write it. I hope you understand now. Although we were not asked to do it, let's say you now want to reduce this, or you want to solve this system of equation. You want to reduce it to echelon form. You understand now? How do you do that? Don't forget, the first thing I ask you to be doing is to what? Is to first of all ensure that what you have here is 1. You understand now? And if it is not 1, you can interact the row. You know, for example, now this is having 1 at the first element here. You can interact the 2 together. You understand? You can interact the 2 together, and it is allowed. So then it implies that this is going to give me what? I can say R3. So I can say R3 corresponding to R1. You understand now? Because we want 1 to start here. That's one of the rules you have to take into account. Or if you don't want to interact row 1 with row 3, what you can do is you can just divide row 1 by 3. You know, if you divide it by 3, you are still going to have 1 here. But the problem you are going to have is that this negative, this second element, we have a fraction, which might give you a problem at the end of the day. So, and if you rewrite it this way, or if you interchange them, this is going to be 1, 1, 0, minus 1. Then this is going to be what? 3, minus 1, minus 1, 0. So, and this is going to give me 0, 1, minus 1, 3. So 0, 1, minus 1, 3. That's first thing. Now, if that is cleared, then we are fine. This is already 0. Then we are still interested in what? In making this guy to be 0 and making this guy to be 0. You understand? If you want to use row reduced echelon form, I'm still coming to Gaussian elimination, because if it is Gaussian elimination method, then we are interested in making this to be this guy to be 100010001, so that it produces the value of S, Y, Z straight away. You understand? But I want you to understand the trick we are using there before I go there. I hope you understand. Okay, now let us continue. Let's say I want to make this to be 0. You understand now? Then you say you write this 1, 1, 1, 0, minus 1, 0, 1, minus 1, 3. So if this is not 0 before, then you have to do that, but it is 0, you don't need to stretch yourself. So to make this guy to be 0, it's just like maybe you have rice, then I have potato, and both of us want to eat the same food. Or let me say, before you can make this guy to be 0, you know, if 3 is here, and I just subtract 3 minus 3, I'm going to have 0. That's just the case. You understand that? But this is 1. How do you now make it to be 3? Just multiply this by 3. And you know, if you multiply this by 3, then you are going to have 3 minus 3. And what you do for one element of the matrix, you have to do it for all of them. That's why you can now say 3 row 1 minus row 3. You understand that? That is 3 row 1 minus row 3. So 3 row 1 minus row 3 means multiply 3 by row 1. That will now be 3 times 1. That is 3. 3 minus 3 will give me 0. Then you still move to the second element again. 3 times 1, that is 3. 3 minus 1. 3 minus 1, that is 3 plus 1. That will give you 4. Then 3 times 0 is 0. 0 minus 1, that will give me 1. Then 3 times minus 1, that is minus 3. Minus 3 minus 0, that will give me what? So minus 3. I hope you understand now. And this one will now give me 1, 1. We've done with that. Okay, now then again, we are still interested in making this to be what? In making this guy to be 0. So we are interested in making this guy to be 0. How do you make it to be 0? Then I can use the relationship between the first and the second what? So the first and the second column here. In essence, I have 1, 1, 0, minus 1, 0, 1, minus 1, 3. So then what if I just say 4 row 2 minus row 1? Who can tell me the reason why it is not advisable to use what? A relationship between row 1 and row 3 here. Because if you use relationship between row 1 and row 3 here, let's say...
Can you please repeat? I didn't understand.
Okay, yeah, thank you. Sorry about that. You understand now we obtain this, right?
You're being too much fast.
Okay, yeah, sorry. I'm sorry, I'll be more slower now. I'm just doing that because of the time, because I know you might have a lot of questions. This is what I'm trying to say. You know, if you want to reduce this is what we had before. Did you understand how we obtain the augmented matrix?
No.
Okay. So if you want to obtain your augmented matrix, for example, we have 3s minus y minus z is equal to 0. This is what we have. Let me just look up. Let's say you have s plus y is equal to 5, s minus y is equal to 3, and you want to obtain the augmented matrix. Then your augmented matrix is going to do what? Just write the coefficient of the variable here. What is the coefficient of s here, my friend? You know it is 1, right? Hello? Can you hear me? You know the coefficient of s here is 1, you write it.
Yeah.
What is coefficient of y here? 1 again, right?
Yeah, 1.
Then you now write dash like this. Then you write what you have here. It's 5.
Okay.
So this one, what is the coefficient of s here again? 1. The coefficient of y here, that is minus 1, 3. So what you've done here is what? You've reduced, you have a kind of augmented matrix. And with this augmented matrix, or you say augmented form, you can use it, you can reduce the row to solve the system of linear equation. Like I've said, you can solve the system of linear equation by using the echelon method or by using Gauss Jordan, which I'm going to explain later. So I'm now explaining when you say something is what? When you want to use row reduce echelon form, when we say echelon form, this is like echelon form, you have to have 1 here. Maybe when I have 1, 2, 3, 4. And the first element of the second row will be 0. Other might be non-zero. You understand now? And the first two elements of the third row will be 2 zeros. Other might be non-zero. And for the third 0 now, it means I'm going to have what? 0, 0, 0. You understand now? And the fourth, I'm going to have 0, 0, 0. So what we have here is known as echelon form. And how do you now reduce, your system to an echelon form? That's what I'm trying to explain here. Okay, now, with what I've explained, let's say I want to reduce this guy to an, I want to write it in an augmented matrix. You know, that's what the question was referring to here. It asks us to write the augmented matrix corresponding to this guy. I hope you understand now. So then I told you, since we note that before we can write it in an augmented form, you have to collect the like times such that your variables will be on one side and the constant will be on the other side. That's why I rewrite this guy. Then I have 3s minus y minus z is equal to 0. You have to have the constant at the right-hand side. So then the second one, y minus z, it is arranged already. This is also arranged already. And don't forget to put it in an augmented form now. Then this is going to be what? 3. So minus 1, 0. And what is the coefficient of s here? It is 0 because it is not there. Then this is going to be 0, 1, minus 1, and 3. So, and what is the coefficient of this one too? So this is 1, this is going to be 1, 1, and minus 1. Okay, for z, z is not there, it's equal to 0. So then we will now want to reduce it to an echelon form. Don't forget, for an echelon form, before it's complete in an echelon form, you must have 1 at the top here. So, and if you now check this, you see it is not 1 before. What you can do is to make it 1 or change one of the rows there to make it 1. That's why I interact row 1 with row 3. You know, row 1 with row 3 will now give me what? So if I interact row 1 with row 3, since this one is already having 1 here, that's why I put it here. Then I'm going to have 1, 1, 0. Then you can put this at the row 3, 3 minus 1 minus 1. It is allowed. You can interact any of the rows, or you can interact any of the rows in the system. Okay, now we are now interested in making this to be 0, this to be 0, this to be 0. Based on the explanation of the echelon form I explained, so this is going to be 0, this is going to be 0, this is going to be 0, 0, 0, 0, 0. Even if you have 10 of them, immediately you have 1 at the top. Then the next column, you are going to have 0. Then the next column, you are going to, the next row, you are going to have 0, 0. The next column, you are going to have 0, 0. So when you have it in such manner, then we said to be in an echelon form. That is 1, 0. Maybe you have 1, 1, 2. Then it's going to be 0, 1, 3, for example. Then 0, 0, 4. So 0, 0. So this is an echelon. That's what we are trying to do here. So okay, now this is already 0. Let us make this guy to be 0. How do we make it to be 0? Multiply 3 by here. You know, if I multiply 3 by all this guy, one of the ways to make it to be 0 is that if this and this are equal, then I can just subtract. And that's why I said, okay, now let me multiply 3 by the first row. If I multiply 3 by the first row and I just say 3 times 1, which is 3 here, minus 3 here, this is going to give me 0. And what you do for an element, you must do it for all the elements. That's why I also said 3 times 1 here again will give me 3. 3 minus 1, that is 3 plus 1. That will give 4. You do it for all of them. You know, now we've accomplished our aim to make this to be 0. Now we want to make this guy to be 0 as well. How do we make it to be 0? Then I'm now advising that if you now want to make it to be 0, you have to consider the relationship between row 2 and row 1. Row 2 and row 3. Don't use row 1 and row 3. What I used to advise my students is that, okay, now to reduce this one, use row 1 and row 2. To reduce this one, to make this to be 0, use row 1 and row 3. To make the next one here to be 0, that is the last one, use row 2 and row 3. You know the reason why? Let's say if I use row 1 and row 3 here, you know what we are going to do, since this is having 4, is to multiply this guy by 4 as well. You know, the moment you say, okay, now 4 times 1, that is 4. 4 minus 0, this will give you 4 back. It will change this from 0 to 4 back. And we are interested in making this to be 0. We've solved the problem. We must not have that problem again. That's what I'm trying to say. I hope you understand now. So that is that. So, but if I use this, if I use the second row, so then if I multiply by 4, you know, this is 0 before. 4 times 0 will give me 0, 0 minus 0. That will give me 0. Also 4 times 1, 4. 4 minus 4, that will give me 0. You know, we've reduced this to echelon form, but we have to continue and do it for all of them. Then 4 times minus 1, that is minus 4. You understand? Minus 4 minus 1, that will give me minus 5. So 4 times 3, that is what? 12. So 12 minus 3, that will give me 15. I hope you understand now. So we've reduced this to echelon form. And you know, one of the advantages is that as soon as you reduce it to an echelon form, you know, this equation will now reduce to what? X. Okay, if you write it, before you put it into an echelon, you know it's going to be S plus Y plus this is 0, right? That's going to give me minus 1. Then this 0, this will give me Y minus Z is equal to 3. And this is going to give me minus 5Z is equal to 15. You know, the advantage of it is that from here, you can know the value of your Z. Once you know the value of your Z, you substitute here to know the value of your Y. Once you know the value of the Y and Z, you can substitute here to know the value of Z, of X. That's what they are trying to say. So if that is clear, okay, look at this, guys. Again, the next question on here before we move to Gauss Jordan elimination method. Look at the second question. The question anybody who will try? Who will try it? You know, it was in. Can you just take it to the form it was before we have the. Hello, please, guys. Can you still hear? This is X. S is not there before. S is 0 here. Just multiply. Just put S, Y, Z here. So since S is 0, this is going to be 3Y plus 2Z is equal to 4. This is going to be what? S minus Y minus 2Z is equal to minus 3. You understand now? 4X. You know, since Y is not here, you just leave it because Y times 0 will give you 0. Then plus 3Z is equal to 2. So that's what you've done. Okay, look at this. Determine which of the following matrices are in row reduced form. So if the matrix is in a row reduced form, then it's not in a row reduced form, state the condition that is violated. Yeah, what condition is violated? You can see that this one is not, this one is there. It is in a row reduced form, echelon form, because don't forget I said you must have one here, one is here already. This is 0, then this is 0, 0. I hope you understand how it is there. This one is not there because what is the first condition? 1 should be here, 0 to be here, but this one should also be 0. You understand now? So that is why it is not there. What about these guys? This one is there. It is in an echelon form. Okay, guys, what about D? Anybody? What of the fourth one? What of the fourth one?
It doesn't start with 1.
So it doesn't start with 1. Then it's not gonna, it's gonna not be there. So that is that. I hope you understand now. So that is that on row reduced echelon form, and that's how you are going to be reduced. Don't forget, the first thing to do is to ensure the one starts, the system. Then for the second row, 0 must start it. The next one will be, the first 2 elements must be 0. Then the next row, the first element must be non-zero. That is when you have something of this nature, then you have 0 here, 0, 0, 0, 0, 0. 0, 0, 0, 0. So that's row reduced echelon form. Another one is now Gauss Jordan elimination method. You understand now? Recall I made mention of what? Or I defined an identity element for you the other time. That is when you see an identity element, that is an identity element is an element. So, I mean, identity matrix is a matrix where all the elements are 0 except those along the leading diagonal. So, which are unity. Maybe you have 0, 1, 0, 0, 0, 1. You understand now? So, when you have the augmented matrix like this, you understand now? So, the process of making your augmented matrix look like this is known as Gauss Jordan elimination method. You understand that? So that you reduce it so that you have 1 here, the rest will be 0. You have 0, 1, 0, 0, 0, 1. You understand now? So at the end of the day, you can now say, okay, now my S is equal to 7, my Y is equal to 6, and my S is equal to 5. That's how you are going to be doing that. But if that is clear, maybe I should give you an example to back it up so that we do it. Or if you have an example on it, you can give that to me. Let me check the question. Do you have a question on that?
Please repeat one more time.
Okay. So this is what I'm trying to say. You know your identity matrix I explained the other time. Identity matrix are matrices where all the elements are 0, 0, 0, 0, 0, except those along the leading diagonal. You know, the leading diagonal is this. You understand now? So when you have this kind of matrix, then we call it identity matrix. That is, you have 1, 0, 0, 1. That's for 2 by 2 matrix. And you know, the application of this matrix is that, let's say I now have an augmented matrix like this, 1, 0, 0, 1. You understand now? Then I have 5, 3. You know, if you want to write it back to the system, to the original system you obtain, what is this going to give to you, everybody? You know, maybe I have S, Y here. It's in terms of S and Y. You know, this is going to give me X plus what? Plus 0, Y, which is 0, is equal to what? 5. This means S is equal to 5. And this one is 0, Y is equal to 3. You understand now? So what Gauss Jordan is saying is that, okay, now if you now have a system, reduce it to be in terms of identity matrix so that you have your identity matrix here. And the moment you now have your identity matrix, you now turn it back to the original system. So this will now give me my S to be 5. Then Y is equal to 6. And what? Z is equal to 7. So, and Z is equal to 7. I hope you understand what I mean. Do you understand it now? So maybe I should.
Thank you, sir.
Yeah, let me give you another example. Let us use this to do it, although it might appear cumbersome, but it should not be difficult. It's naive. So honestly, it is not difficult. Just know that you just know what you want to have, and just simplify it. I hope I've clarified the difference between using row reduced echelon matrix and Gauss Jordan elimination method. For row reduced echelon matrix, just reduce it for put it in an echelon form. That is 1, 0, 0, 0, 0, 0, 0. I hope you understand that. That's for row reduced echelon form. You understand? But for Gauss Jordan, so then you have to have 1, 0, 0, 0, 1, 0, 0, 0, 1, so that you have it in terms of it. I hope you understand now. So, okay, guys, if that is clear, let's say we want to reduce it. First thing to do is to what? Is to write it in an augmented form. What's going to be the value in an augmented form? Everybody, please. Just write the coefficient. This is going to be what? 2, 3, minus 2, 10, right? 3, minus 2, 2, 0, 4, minus Y, minus 1, 3, minus 1. I hope you understand now. So What are we interested? We are interested in making this matrix to be what? This guy, we are interested in reducing it to 1, 0, 0, 0, 1, 0, 0, 0, 1. So that at the end of the day, what we have here, we can just say our S is the value of this, Y is the value of this, and Z is equal to the value of this. Okay, now, should we start? First thing to do is to ensure that this is what? This is 1. I hope you understand now. How do you make this guy to be 1? And it being one of them is 1, you can just interchange, but it is not. Then how are you going to do that, anybody? I can just say my R1 divided by divided by 2. You know, if I divide all of them by 2, it means this is going to give me 1. Guys, I hope I'm communicating.
Yes.
Hello? Okay, thank you. Yeah, please, if you have a question, do not hesitate to ask. I'm here purposely because of you, please. So then 2 divided by 2 is going to give me 1, 3 over 2 minus 1, 5. You know, we've made it to be 1. You understand now? Also, we want to make this to be 0. Or maybe let me write it first so that we don't stress ourselves. 3 minus 2, 2, 0. 4 minus 1, 3 minus 1. I hope you understand now. So, oh yeah. Okay, now, to make this, we have 1, 3 over 2 minus 1, 5, right? How do we make this to be 0? You know, we are interested in having 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, let us make this to be 0. How do you make this to be 0? Just say 3 row 1 minus row 2. It's because we want this guy to be 3. The moment it is 3, I can just say 3 minus 3 straight away. I hope you understand now. Then you have 3 times 1. That will give you 3. 3 minus 3, this is going to give me 0. Then 3 times 3 over 2, that will give me 9 over 2. 9 over 2 minus 2. That is plus 2. Then you have 9 over 2 plus 2. Then if you find the SCF, you have 2, 9 plus what? 4. That's going to be 13 over 2. You understand now? Okay, likewise, 3 times minus 1, that's going to be minus 3. Minus 3 minus 2, that's going to give me minus 5. 3 times 5, 15. 15 minus 0, that is 15. I hope you understand. Okay, I hope you understand how we obtain this. Let us obtain this. Who can tell me the rule we are going to use to obtain this one? Anybody? Anybody, please? Anybody? So that I know you are following me.
Sir, is there a way to do this without making fractions?
Without making fraction? Is that what you mean? Please repeat what you said. I didn't get you clearly.
Sir, I asked if there's another way to do this without making fractions.
I still can't hear you, Syria. Were you asking about the fraction? That is, can we do it without having fraction? Yes, we can do it without having fraction, but with the look of the system, you can't do it without the fraction. You know what I could have done is that I should interact the row with the one starting with 1, but none of them is starting with 1. So we don't have option. So what we can do is to just do it like that. You understand now? But I'm asking, how do you reduce this to 0 as well? What you can do, okay, someone has just typed. Yeah. So this is going to be 4 row 1, because this is 4. Before I can make it to be 0 is to make this guy to be 4 as well, so that 4 minus 4 will give me 0. So 4 times 1 is 4, 4 minus 4, this will give me 0. Then 4 times 3 over 2. 4 times 3 over 2, I think that is 6, right? Can you see we've get rid of the fraction now? Then 6 minus 1, that will give me 7. You understand? Okay, 4 times minus 1, that is what? 4 times minus 1, that is minus 4. Minus 4 minus 3, that is minus 7. 4 times 5 is 20. 20 minus minus 1, that is 21. Can you see that now? God, thank God we make it to be what? We make it to be 0. Okay, let us make this guy to be 0 too. How do we make it to be 0? Or if you don't want to stress yourself, why not divide it by 7? You understand? So that we have 1. So then I can say 1, 3 over 2. Although it might look, but it is not difficult to do, just be doing it one by one and it won't give you any problem. 15, 15, and this is, okay, what I want to do is, let's say R3 divided by 7, because we want to make this to be 1. So R3 divided by 7, 0 divided by 7, that is 0. 7 divided by 7, that is 1. Minus 7 divided by 7, that is minus 1. 21 divided by 7, that is 3. You see what I mean? Okay, now let us make this to be 0 as well. How do we make this to be 0? Is to make this also 13 over 2. I said if you want to reduce this to be 0, you have to be careful. Use, the relationship between this guy and this guy. Don't use between 1 and 3. You understand now? So, okay, now, what are we going to do? We have 1, 3 over 2, minus 1, 5, 0, 13 over 2, 15, 15. Okay, then you can just say R2 minus 13 over 2, R3. You understand now? So R2 0 minus 0, this will give me 0. 13 R2 minus 13 over 2 times 1. That is also 13 over 2. 13 over 2 minus 13 over 2. That's going to give me 0. Okay, this is going to now be 15 minus, 13 over 2 times 2 will give me 13 over 2. You understand? Then you have 2 here. 2, that is 30 minus 30. That will give you 17 over 2. I hope you understand now. Okay, let us do the last one. So that is 15 minus 3 times 13 over 2, right? 3 times 13 over 2. Your SCM is also 2. That is 30 minus what? 39. That will give me minus 9 over 2. So we are getting there. We are getting there. Okay, now, what else can we do? Let's say how we can make this guy to be 0 as well. How can we? Because we want to make this guy to be 0. We want to make this to be 0. We want to make this to be 0. Okay, how can we do that? Anybody? Let me make this guy to be 0. Anybody, any idea? Yeah, that is not difficult to do. So I can make this to be 0. If you don't know something, you can just multiply this guy by this guy. It's just like I'm having rice and you're having potato, and we want both to eat the same food. You can just give me from your potato, then I give you from my rice, and we eat the same food. You understand? So to do this, just say 3 divided by 2 R1. You understand? Then minus 13 over 2. No, sorry. Because I want you to give me potato while I give you rice. This should be what? 13 over 2 R1 minus 3 over 2 R2. So, and this one, we can't do that. That is not possible because this one is going to give me 0 as well. That's going to give me 0 as well. We can't do that. Never. We can't do that. Maybe we should match this with this. Let's see what we can do. That's what I'm trying to avoid before. That's what I'm trying to avoid before. Okay, anybody, any idea? Okay. What if we use the relationship between this guy and this guy? It's not going to. It's not going to be the same. I'm coming. Then let's think how it's going to be 1. Let's think how it's going to be 1. Yeah. Another way we can do is, let me reduce this guy first. Let us reduce the third one first. Sorry, my system is rolling. I think it is tired as well. So what I'm trying to say now is that while we are waiting for it, you can multiply this by 2/17 so that this one will remain 1. So that this one will remain 1. Okay, and this one, hope we not make a mistake because it should not be this. Or maybe we can just try and make this as 1 as well. If we make this as 1, you multiply by 2/13. You multiply by 2/13, then this is going to be 1. And if it is 1, yes. So if this guy is 1, then I think we can marry the 2 together to give us that. So we can marry the 2 together to give us that. Okay, let's wait for it, sorry. So because this one, we must have 1 and we must also have 1 here. Then it will just be left with this guy and this guy. Yeah, let's do it. Or maybe why not close it and open it again? Let me reopen it again. Oh, what's wrong? Yeah, sorry guys, I want to open it again. So it's just like that, you don't need to stress yourself. Okay, let me share the new screen. Okay, so look at this. Don't let us use that. Let us reduce this guy first. Now let's make this to be 1 as well. Let's make it 1. So then this is going to be 1, 3/2 minus 1, 5. How to make this one? Just multiply it by 2/3. That is 2/13 times R2. You know, if you multiply 2/13 by 13/2, it's going to give you 1. Then this is going to be 0, 1. Then 2/13 multiplied by 15. That will give you 30 divided by 13. And this also gives you 30 divided by 13 since it is the same 15. Okay, what of this? This is going to give you 0. This is going to give you 0. Okay, let's say we want to reduce this as well. I can just say 2/17 again. This is not there. 2/17 multiplied by R3. That's going to give me 0, 0. If you multiply 2/17 by 17/2, this is also going to give you 1. Okay, 2/17 multiplied by minus 9/12. 2 here 1, 2 here 6. So that's 3 here 2, 3 here 3. Then I'm going to have minus 3 divided by 34. Can you see now we have 1, 0, 0, 1, 1, 1. Then we want to make this as well, 3/2, 3/2. Okay, now, what will tell me how we are going to do this, how we are going to get that? Because that is strange. That's the only thing we need. That's the only thing we need left. I want to make this guy to be 0. Yeah, I see what we can do. I hope you can. Are you seeing what I'm saying? Look up. This is what I'm trying to say. Now, let me change the marker so that you can see it. What if I say R1, you understand now? R1 minus 3/2 minus 3/2 R2. R1 minus 3/2, that is 1 minus 3/2 R2. You know 3/2 times 0 will give me 0. This will remain 1. Then 3/2 minus, you know 3/2 times 1 here will also give me 3/2. 3/2 minus 3/2 will also give me 0. Then this will now be minus 1 times 3/2 2 times 30 over 13. Let's say that is what? 90 over 26. 90 over 26. Likewise, when you multiply it by what? So we have 5 times 3 over 2 times 30 over 13. 3 year, 2 year, 1, 2 year, 15. Then you have 45 over 13. This is going to give me 45 over 13. Then what do we have left? This is also 0. This is 1. This is 30 over 13. This is 30 over 13. Then this is 0, 0, 1, then minus 3 divided by 64. We are getting there. And don't forget, what is left is to make this guy to be what? Is to be 1. And that is not difficult to do as well. Just multiply by, what did I write here? 26, right? I think it is 26. Yeah, just multiply by 26 over 90. Then I can just say 26 over 90 R1. Oh, that is not true. You can't do that because it will affect this. Don't let us do that. Don't let us do that. Let us make this to be 1 as well. How do we make this to be 1? So multiply it by, we have 1, 0, 90 divided by 26. You know, it's something, but you have to think. So I know where you are going. Okay, let's say I say 13 over 30 R2. So no, this is not done as well because this is going to give me 0, 2. Then I should make this, as make the relationship between the third and the second one. So you have to be thinking about that so that you don't make mistake. So I can just say R2 minus 30 over 13 R3. R2 minus 30 over 13 R3, that's 0 minus 0. This will give me 0. 1 minus 0, that is also 0. This will also give me 0. You understand? And no, this is 1, no. Because R2, that is 1 minus 30 over 13 times 0, that is 0. 1 minus 0 will give me 1. Okay, what of this? R2, that is 30 over 13 minus, so 30 divided by 13 multiplied by, oh, this will be plus because of this minus, multiplied by 3 over 64. You understand now? Okay, let's see what can go. This is 15. Or let me just, maybe I should multiply it together so that I don't stress myself. So yeah, if you multiply it together, you are going to have this because of the time. So then you have 0, 0, 1. What is left is just this guy. You understand now? What is left is just this guy. And you can easily reduce this by using this approach, this and this. Just multiply this guy. I mean, just say R1 minus 90 over 26 R3. You know, this is going to be 1, 0, and this will give me what? 0 again. Then you have it now. Then you can now say directly what, maybe I should do that, but just that because of the calculator I don't have here. So this is what I'm trying to say. You know, if you say R1 minus 90 over 26 R3, then it's going to give me 1, 0. 90 over 26 R3 minus 90 over 26 is going to give me 1. What you have here, then 0, 1, 0. What you have here, 0, 0, 1. What you have here. Then at the end of the day, you can just say your S is this. Oh, no, but before you do that, then we don't have, this one is not 1 yet. No, this will be 0 because 90 over 36. 90 over 26 minus 90 over 26, that is 0, not 1. So then you can say this is your 1, S is equal to this, Y is equal to this, and Z is equal to that. That's how you are going to be doing that. I hope that's clear. As I know it might look cumbersome, but you don't need to stress yourself. It is just like that. So, okay, now I don't know if you still have other questions before I call. I think that's Gauss Jordan elimination method. So you can just use that directly. What do you think? Any question? Does that sound like something you understand or what? Hello, guys. Let me know what you think.
I think we understand.
Okay. Thank you. And sorry if it looks like, yeah, that's that's how it's, some of them is just. Okay, any other question, please? Yeah, let me see some of the past questions. I think we've done this. Okay, look at this question. This question is on MCQ as well. This question is on MCQ. Let me just snap it straight away so that you can see that clearly. Can you see the question I just copied? Guys, can you see the question I just copied?
No.
No. Yes,
now? Right, okay,
Now
thank
we
you.
see.
So look at this question. The question says, consider the system of equation s plus y plus 3z is equal to -4. S plus 2y plus z is equal to 7. S minus 2y is equal to 1. Then we use Gauss Jordan elimination method and perform the following row operation to the augmented matrix of the system. Then the question asks us to do what? The third column of the equivalent augmented matrix is this. Yeah, they want you to find the third column. What you have to do is what? You have to rewrite the augmented matrix. You know, you don't have the coefficient of s here. This is going to be 0. This is 1. This is 3. This is -4. This is 1. This is 2. This is 1. This is 7. This is 1. Since we don't have, okay, we have y, but not z. This is going to be 0, and this is going to be 1. I hope you understand now. And the question asks us, you know, the first rule here is to interact row 1 with row 2. To interact row 1 with row 2. If you interact row 1 with row 2 here, what are we going to have, guys? What are we going to have? You know, the first thing I ask you to note is that what you must have as the first element is 1 on top of it. You understand? And this is not 0. Then they suggested we interact row 1 with row 2. That is, if you change row 1 with row 2, change this row, bring it to the position of row 1. You understand now? And the second row like that. So then it means that's going to give me what? 1, 2, 1, 7, 0, 1, 3, -4. Does that help? Hello, guys? Yeah, okay, thank you. Okay. What is the second rule? That is R3 minus R1. Okay, let us subtract R3 minus R1. R3 minus R1, that is, we are interested in making this to be 0 since it's a row reduced echelon form. That is 1, 2, 1, 7, 0, 1, 3, -4. Okay, when you subtract row 1 from row 3, yeah, 1 minus 1 is 0. 2 minus -2 is 4. 1 minus 0 is 1. 7 minus 1 is 6. Okay, and lastly, what is the last rule? Okay, the next rule, we have to do R1 plus half R3. R1 plus half R3. R1 plus half R3. Okay. R1 plus half R3 and R3 plus 4 R2. R1 1, 2, 1, because they want R1 plus half R3. Do you know what they want to reduce here? They want to reduce this guy to 7. Let me write it. 0, 1, 3, -4. Okay, R1 plus half R3 plus half R3. You know R1, that is 1 plus 0, that will give me, no, then it is not applicable to this. Then they want us to implement it here. Because you may implement this here, it's going to give me what? You know, it's going to give me 1 back. Then we are wrong. Then we are wrong. We are wrong. So this is going to give me R1 plus half R3 that is 1 plus 0, that is 1. 2 plus half R3. Something is wrong. Well, it's supposed not to be that. I hope we've not made a mistake of negative. Minus. What is wrong? Because they performed the 2 operation here. R1 plus half R3. Then it means we've made a mistake of negative. We made a mistake of negative somewhere. Can we check that again? 0, 1, 3, minus 4, 1, 2, 1, 7, 1, minus 2, 0, 1. Then if we interact that, we have 1, 2, 1, 7, 0, 1, 3, minus 4. Okay, R3 minus R1, that is 0. We implemented it here. R3 minus R1, that is 0. 2 minus minus 2. This is 1. Yeah, I think we are correct. Okay, let's implement what they asked us to implement. Just that the question seems because they are supposed to give us the row we are going to implement it. So they are supposed to give us row we are to, okay, R1 plus half R3. But to the best of my knowledge, they want us to get rid of this guy. Okay, let's continue. R1 minus half R3, this is 1. So then R1 plus half R3, you know, this is 2. Half of this is also 2. 2 plus 2 will give me 4. R1, this is 1 plus half of this, that is 3 over 2. This is 7. Half of this is 3. 7 plus 3 is 10. You understand now? And what is the next row? Maybe you can just leave this as it is, 0, 1, 3, minus 4. And what is the last row? Last row, R3 plus 4R2. R3 plus 4R2. R3 plus 4R2. And this is going to give me 0. Can you see there is a mistake here? Because this is going to be minus because they want us to get rid of this. I think this is supposed to be minus, or maybe we've made the mistake of minus somewhere. Did we? I don't think we make a mistake. Then definitely the mistake is actually from them. Because if we want to reduce this, guys, this is supposed to be negative. So that this will be 4 minus 4 is going to be 0. I hope you understand now. Then this is 1 minus 1 is going to give you 0 as well. Then this is 7 minus, so this is going to give me 1. You understand? And if this is negative, then 1 minus 0, okay, R3 minus 1, so this is going to be 0. 4 minus 4, this is also going to be 0. So then R3, so what is R3? 1 minus 12. 1 minus 12, that is minus 11. Then 6 plus 16. 6 plus 16, that is 22. Yeah, I think we've performed all the rule if we've not made a mistake. Then the question asks us the third column of the equivalent augmented matrix. This is the first column. This is the first column, this is the second column, and this is the third column. That will be 0, 3, 0, 3 minus 11. I think it's more closer to this. Maybe we made a mistake where we are converting this. So just recheck them again. That's what you are going to be doing. Just do the rule again. And at the end of the day, you trace it to the column you are asked to find, and that will give you your answer. Let me take 1 or 2 questions before we call it a day because the time has gone. Any question from the group? I hope you understand, guys. Hello, can you hear me? Do you understand?
Yes, we
Yeah,
understand.
I understand. Thank you.
Yeah, please. I wish you the best of luck in your assessment. So at any point, if you have a question or query, then you can send to my email. So I'm going to assist you with that. So I've recorded the session and I'm going to upload it for you to see as well. So I wish you the best of luck. Thank you so much,
Thank
guys.
you.
So,
Thank you.
okay. Bye-bye.